So I make that 10 o'clock by my laptop, but I don't know how accurate my NTP source is. So hello, everybody. Let's start the meeting. A few people can dribble in at the back. It's absolutely fine. So this is Reliable and Available Wireless, Raw. This is not the wrestling organization. This is actually an IETF working group. So if you're in the wrong meeting, now's your chance to leave and take your plastic chairs with you. Sorry, bad joke. So Eve, unfortunately, wanted to be here in person, but can't make it. So she's dialed in remotely, so you just have me in the room. But I think that should be a pretty good combination for both of us. So first off, this is an IETF working group meeting, therefore covered by the note well. I'm hoping by Wednesday you will have at least come across a note well before. I'm not a lawyer, but as I am led to believe by people who are, basically this means anything you contribute at the microphone or in chat or submit to the mailing list is covered by, you are releasing that IPR. If you have any concerns over this, please consult the references in the note well. Please look at it as a serious document and try and avoid making any mistakes. If you are unsure, don't say anything, read the note well, and then say something. This is freely available in various places in the IETF, so I suggest you go back and look at it if you haven't read it before. And this is a list of reference to the various important parts in here, including code of conduct as well as copyright, etc. So important tips, given this is a hybrid meeting, we have people in the room and we also have people remotely, and in order to ensure that we can maintain a single queue for comments, etc., I recommend everyone in the room uses the Meet Echo, either the on-site tool, there are QR codes liberally scattered around the room which take you straight to the on-site version of the tool, which allows you to join the queue and get yourself out of the queue quite quickly and easily. Those of you, well, it seems a bit strange thing to say. Those of you who are at home dialed into Meet Echo, you need to dial into Meet Echo. But if you are listening to the audio stream, there is Meet Echo, which gives you a nice video conferencing facility, and you can see the slides as well. Information on that, I believe we put on the next slide. Right? Yeah, here we go. So information on how to get access to Meet Echo is available via the data tracker, and the agenda also has links to it as well. So good news, we don't have to fill in blue sheets anymore. It's all automatically done through your login to the various Meet Echo things. We have an integrated note-taking facility built into Meet Echo. We would like people to use it. Please make sure that someone is collaboratively recording some minutes. If anyone wants to put their hand up and say, I want to be the main driver of that, that would be great. Otherwise, please ensure, if you're making a point at the microphone, that your name is spelled correctly in the minutes and that the meat of what you were trying to say is also recorded in the minutes, just so that there's no confusion at a later date. The link to the built-in HedgeDoc tool is also on this slide, as well as there's a convenient button in Meet Echo. As ever, we have a mailing list. It's raw@ietf.org. If you need to contact the chairs for any reason, there's raw-chairs@ietf.org. That is not on the slide, but is in the data tracker. And all the meeting materials for this session are also available through the data tracker. So, formatting's gone great. Our agenda for today, the intro by myself and Eve. And Eve, please just jump in if you have any comments. It's always difficult when you're at home at the same time. We're going to kick off with a discussion about the Ldx draft, which has gone to the ISG, has had a number of review comments, and I'm looking at John, our AD here, because I think we just need to have a grown-up conversation with you about what do we do now, because we've got a bit stuck between the authors, the chairs, the working group as a whole, and the ISG reviewers, and we need to think of a way forwards here. There's been some discussion, but I'd really like to get that resolved. But meanwhile, Niels will do a quick presentation on what last-minute changes have gone in there. Pascal has a 40-minute slot to talk about the architecture document. For those of you who aren't aware, well, I hope you're aware, we've had a couple of quite productive interim meetings talking about the architecture, asking ourselves some serious questions about what do we mean by raw and what should be in this initial architecture document and what should be work items that are going to live on in the framework document, which is designed to be a living doc to describe our thoughts and to capture the sort of direction of the working group, to be published at the sort of end of this charter cycle. So Pascal's got a nice big slot to talk about that, because I think it's the meat of the working group's work at the moment. We got a Wi-Fi update from Jérôme Henry, I believe, or being French, it may just be Henry, I'm sorry if I've mispronounced your name, talking about what IEEE are doing in terms of reliability in the new Wi-Fi specs that are coming. Carlos has got a short presentation on the latest updates to the use cases document, what's happening with that. I have an apology to make there. It was looking for a document shepherd for a while. It was ready to go to ISG, and the chairs dropped the ball on that. It should be getting a write-up. It should be ready to go pretty soon. So hence just a quick one from Carlos. He's also presenting about the multi-domain extensions. So that's reasonably new work, and that will be interesting. So looking forward to that. And then Bob Moskowitz has asked for a 15-minute slot to talk about transports that would run over a RAW/DetNet network. So once we have built this technology, we've got the control planes in place, we can start to lay down some reliability from end to end. How do we make transports not do the dumb thing on top and then break all our hard work? So I can see that being interesting, contentious. It may not be a perfect topic for RAW, but it's a great place to start the discussion. And I'm glad we've got a couple of ADs in the room, because I imagine there'll be a discussion about, does this get shoved across to transport, etc. And then we've got 30 minutes open mic, which will turn into 30 minutes of we've eaten that time by overrunning constantly, but it gives us a bit of buffer. But there'll be a chance for people to raise any other business at the end. So there we go. Would anyone like to bash that agenda at this point? Has anyone got something vital they want to take to the mic now, or should we just move on? Silence is assent, so we'll move on. Eve, do you want to take over for a second so I can have a quick drink and just talk us through where we are with the document status?
Well, I think that you did a very good job in the intro as well. So let's just review what documents exist and where they are. As you heard, we are hoping to get some advice and guidance around what our next steps are for the Ldx document. The use case document is awaiting the write-up. Oh, no, sorry. The use case is also in the review phase, but it's the raw technologies document that awaits the write-up. We have had these multiple interim meetings to make progress on the architecture document. And so fortunately, it is shaping up. And we have segregated the framework, which is sort of the future-facing, what do we do, from the architecture, which kind of outlines what the problem statement is. The raw OAM support document is also making progress. That is something that has, in a previous incarnation, been separated from the DetNet OAM document, which has been making steady progress. We also have an industrial requirements document that, although it is expired at the moment, we did get confirmation from the authors that they are going to renew that document, and we felt that it was pretty close to submission, or at least ready for working group last call. As Rick had indicated, there are some other documents that are under consideration that are more recent documents, and there are three of those. These fall into Carlos's camp. The joint selection, the raw joint selection document that is related to the MEC technology, and then a more general MEC technology draft, and a multi-domain draft that, again, we will have a little bit of discussion about it here today, and it also is getting some discussion elsewhere. I believe there's some discussion about multi-domain in the DetNet agenda as well. That is our document status.
Do you want to cover the milestones while you're happily talking?
No, I think I will leave that to you. It actually appears rather small on my screen here.
Oh, okay, no worries. So just a quick update on where we are in terms of the chartered milestones. Short answer is we're about halfway, purely by count. So we've got sufficient, which is good for a working group, to be honest. We still have a few more things to get ready for the IESG. One major document that we will approach towards the end of this charter cycle is, or actually we can start working on now if there's people who are interested in contributing to it. In the charter, there is a line to say the working group will produce an evaluation of existing IETF technologies and produce a gap analysis document. So this is all about not reinventing the wheel and coming up with unique solutions based on our understanding of the problem space, but understanding what the IETF has already got in its toolbox to solve some of these OAM issues, some of these control plane issues, some of, this may cross over into T's, this will definitely cross over into DET, and to make sure that we're not inventing yet another protocol because we didn't talk to anyone else. So volunteers to start that document or some way to collaboratively work on that document. It's quite an important milestone, and I just want to highlight that to people. Otherwise, we are ticking off milestones, which is good, so 50% through. Okay, so now we will start on the main agenda. So I think first up is Ldx with Niels. If you are online, I hope you are. I think I saw you earlier. I will share your slides and pass you control.
Sounds very good to me. Perfect. Thank you for the kind introduction. It's good to be back at the IETF, even remotely in that case. I've had the pleasure to present the latest version of our draft, so that's the version 11. Actually, just this morning, we pushed version 12 because we realized we had one small typo in it, but that's a different story. Let's focus on version 11 because the main changes were made. So, as already said, yes, not well. I think you covered that extensively. Here's the abstract, or basically the front page. And compared to last time, we added one very important sentence, and that is the intent of this document is to introduce Ldx to the IETF community, raise awareness on related activities inside and outside of the IETF, and to seek expertise in shaping the shift of aeronautics to IP. So what we want to say as authors of this document is that we do not bring Ldx as an externally defined data link to the IETF and then expect that the IETF standardizes that data link. But what we want to do here is basically inform the IETF and seek counsel on that the entire aeronautical communication is now transitioning from previously analog to proprietary solutions now to the IP world, and basically the new data links defined such as Ldx. And as I said, we wanted to raise awareness and seek counsel on how to proceed here, and this is why we thought it's very important to mention that right there in the abstract what the intent of this document is. As you can see, there were quite some changes since last time, so every blue dot is one big change actually. And because we got so many reviews, and actually really have to thank the ISG here for their hard work, because I think in the end it was like 40 word pages of emails and comments, and we incorporated all of the requested updates. And I try to summarize them in the major issues. And those were that one question is that how is Ldx actually interacting with IPv6? And also that there was a request on details on the frame structure and protocol. Again, the second request was with IPv6 over Ldx, how that is handled. And also because Ldx is part of a concept called the Future Communications Infrastructure. And the future communications infrastructure consists of satellite communications for oceanic polar remote domains. We have Ldx, which will be focused on large-scale continental terrestrial communications, and already rolled out for airport communications is the Aeromax. And the entire idea is basically that you're able to switch between data links depending on your needs, or if one link is down, you can seamlessly switch to another, so no packets are lost. And this is why this question was raised, how the FCI is interacting with Ldx and also how handover works there. Then several big issues that were mentioned were, what is the intent of this document? What do we want to do? And does it pass consensus bar set by the RFC 8789? That's something that the authors cannot decide. This will have to be decided by the ADs or the ISG. And also the security part had to incorporate IPv6 security considerations over Ldx. And there's another issue that came up. Unfortunately, many of the aeronautical standards are behind a paywall. So for further review, we can give out those documents by some special access. But unfortunately, as I said, these are behind a paywall, so it's really hard to review the document if we cite them directly. So here are the main answers. So what is Ldx? Ldx is actually a layer 2, a link layer technology that is standardized currently with the International Civil Aviation Organization. And the intent of this draft is basically to introduce the IP supporting data link to the IETF community, because simply saying here's a 400-page document specifying Ldx, have fun with it, didn't really seem like a good idea. Then the second part is that, as I said, current aeronautical communications is transitioning to the IPS, that's the Internet Protocol Suite, that is currently also defined at the ICAO, and Ldx will be one of the access technologies enabling that part. Then there was this question with IPv6. So actually just the last 2 weeks we had a major flight campaign demonstrating what Ldx can do, also with IPv6 end-to-end connectivity, and demonstrating, for instance, CPDLC, that's basically a chat application between the aircraft and the ground, so pilot and air traffic controller. And this CPDLC was secured by DTLS, and so yes, everything was done by IPv6. And how that worked was that Ldx defines 1536 byte large user data packets, in which then the IPv6 traffic is encapsulated. And because ICAO decided that the transport protocol should be UDP in any case, so basically this is how it stacks up then. Then the handovers, because there was one question, we also demonstrated that during the last 2 weeks they are seamless and basically transparent to the IP layer. So you switch from ground station to another, you don't see any hiccups on the data link, so you don't really experience large latency if you're transitioning from one ground station to the other. It's just you switch over and the packets go through and you notice basically nothing. Then, as I said, with the future communications infrastructure, with the different data links, Ldx is a part of that. I already mentioned that. And the important thing here is that there's also a mobility solution envisioned now for an IP mobility solution envisioned for the entire thing. So for the flight campaign, we used for the access network PMIPv6. And then for the FCI multilink concept, there's current work going on to use a list-based mobility solution for switching between FCI links. However, this is not a part that is obviously standardized itself by Ldx, but is some idea that Ldx will play a part in. Then the last two things, Ldx as a link layer has security defined for user and control plane. So before an aircraft can actually successfully communicate with ground, mutual authentication between ground and aircraft are happening already on the link layer, because the radio is the first to make contact between air and ground. So there will be mutual authentication and key establishment, key derivation, and from there we have necessary keys to secure user data on the link layer, but also the control data of Ldx. And this will also majorly help integrity and authenticity, protecting the necessary control messages over the air gap. And the last point, as I already said, so for future reviews, or in case anyone in the audience is interested for reviewing this document, we can provide the standards behind the paywalls for review purposes only. Now, I used already a lot of my time, so let me be brief with the rest of the presentation. What did we change in the text? So as I said, first part in the introduction, what is the actual intent of this document? I already covered that. The second part was that we were asked that the terminology, chapter 2, should be renamed to acronyms, and also we streamlined that. The next part was that we were asked what sources are available, what standards are available, where you can find out, hey, how is IPv6 over either Ldx or any other multi-link candidate handled. So we added in the references where applicable, and also to the FCI and its data links. Then the applicability, I already said that. So within the Ldx access network, local mobility solution will be PMID v6, and within the FCI, the global mobility solution will be implemented on top of Lisp. And we had some questions about the APNT, which is that you can use Ldx also for navigational purposes. And if you have several ground stations, you know the channel quality, you know their exact position, you can basically navigate via Ldx, which has also been demonstrated already 2019. Next part was how is the setup? So this is with the characteristics here on the right-hand side. The ATN is the aeronautical traffic network. So that's where air traffic controllers put in their traffic. Then the air ground router is the interface to the access network. Then we have the several ground stations connected via control plane, but also user plane. And the ground station is the actual Ldx ground radio connected to the aircraft then. For the protocol stack, I would refer to the draft if you're interested in finding out more details, but we updated that now to include all kind of control traffic, which hasn't been included before. About reliability and availability, we clarified that priorities are managed by the diffserv classes. CS1 is the lowest priority, CS07 is the highest priority. So we have prioritization between 8 different traffic classes that Ldx supports. And multiple ground stations are visible to the aircraft at the same time. So for the cell planning, it's absolutely possible. Let's say one ground station is down for maintenance. The signal power is strong enough that I think if even 4 ground stations within the same region are cut out, you can then seamlessly simply switch to the 5th and still continue service as usual. For security, something very important that I wanted to mention here. So what's the security requirements for Ldx? And to put it in a nutshell, to provide a secure channel between the airborne radio system and the peer radio access endpoints on the ground to ensure authentication and integrity of air-ground message exchanges. So basically, entity authentication falls under this category, and then establishing keys, deriving them and using them to secure especially authenticity and integrity of the air-ground messages. Confidentiality is something only kept for certain kind of traffic, actually. Now, I'm at the end of my presentation, and now my questions to the chairs. So we worked extensively on this document over the last 3 months. I think we covered every aspect that we could cover by the comments. And now the question is, how do we proceed from here on out? So thank you very much for your attention, and I'm really happy for a short discussion.
Thanks, Niels. So I'm sure those of you subscribed to the mailing list will have seen a number of messages from myself, from Eve, from John. So some of the feedback we got from the IASG review was, this is a very nicely written document and explains this technology in an interesting way. Is it relevant to the IETF, and how much has the working group actually read and agreed around the validity of this document as a raw working group document? Because searching back through the mailing list archive, some of the reviewers said, there doesn't seem to have been much discussion on this. So a poll of the room and online, quite quickly, I'm going to try and see if I can use the polling button actually. How many people have read this document? Not necessarily the latest version, but a version of this document. And we'll use the show of hands tool so we can see. Have you read Ldx? Question mark. So I'm going to give that a couple of seconds because this is one of the critical questions we need to answer back to the ISG reviewers. I'm going to make it quick. I'm going to stop it at that point. So we got 13 yes, 8 didn't bother to raise their hands. We got 21 participants. So I think that's a result to take back to the ISG. I'm not going to try and interpret that result, but it's not 2 out of 21. The next question really was, is this document, which is a description of the Ldx technology of relevance, and as I understand the author's pitch, that is written to be relevant to the Raw working group and the IETF as a whole, so that we can understand the capabilities of Ldx as an input to any deterministic networking over wireless mediums that we might want to do. I think that's the purpose. It's not to say this is Ldx as an IETF technology. This is Ldx. It could be useful as part of this larger L3 stuff we're talking about. Go on, Lou.
Lou Berger, I suggest you redo the poll. Some of us were not on the tool, and you've now jumped to 39 people in the room.
Oh my lord. Okay,
And
I
so-
will do that poll again.
Yeah,
Yep, and I'll leave it running longer. Have you read Ldx Part 2? It's got a backslash. Hold on, I can't type and speak. Okay, can you raise your hand again, even if you did on the previous one, because I have messed up. But and I'll leave that running a little bit longer. I'm looking at John RAD. Is my summary of my understanding of the review comments accurate?
Yeah, I think that's perfect.
Sorry?
Yes, I think that's perfect. I mean, in fact, I'd put my hand up earlier to stand up and comment, and you said everything I wanted to say substantially, so I took my hand down. Yes, I think that's right.
So my question, or even my question, and actually echoing the authors here, what do we do now to unblock this? And I know I'm slightly unfairly looking at you, John, and we're at a bit of an impasse when it comes to the ISG here.
Right. No, I think you're fairly looking at me. It's right. So you highlighted exactly the right question, because all of the other things that Nils summarized in his presentation essentially take care of essentially all of the discussed comments that were gathered. There was one procedural one that was up to me to take care of, and that one is also sorted. So really the question comes completely down to, do we have consensus within this working group that this is something that we want to, basically all the stuff you just said. Yeah. So, and as far as I know, as you summarized, to date, we don't really have a documented trail that says so. So I think the way to break that logjam is if everybody who raised their hand, which is a decent number of people, and is certainly, as you said, larger than 2, would take the additional time, maybe this afternoon, to write a short email to the list expressing their comments, whether good, bad, or indifferent, about the suitability of moving the document forward and publishing it. That would help tremendously. And I think that if that is done, I don't foresee a problem. I mean, assuming that the consensus is positive, of course. But if that all happens, I don't see any, structural difficulty with going ahead and moving to publication. That of course assumes, I forgive me, I haven't gone and reviewed all of the changes. And so, we'll need to go and negotiate with each person who's raised a discuss and ensure that they're satisfied with the resolution of their discuss. But I have confidence that that's possible. The only thing that's really a sticking point is what you were talking about.
Yeah. So does it have consensus and review from the working group was kind of the crux of the question. So please put some comment on the mailing list, because that is then evidencing, and then we can have a strong argument with the ISG about that. Go ahead, Bob, you're in the queue.
I am being dragged, screaming, but not necessarily kicking, more into this space. There's my work in IKO. And look, I have not given this document the full review that I need to give it. I've given a very cursory view so far. And I'm wondering if, I don't want to delay things necessarily, but perhaps some text as consideration guidance in Raw in what the experience of Ldx provides to Raw in general, in terms of how you look at the wireless side of it, so that any other wireless group, as I'm aware of some other wireless bands which are allocated, which have not done FiNMac at all yet, and haven't worked out yet how to share it. But how
So
to
to answer
go
that,
to
Bob, sorry, we have a use cases document which does draw out some of the avionics use cases and does make mention of Ldx. We also have the technologies document, which does a broad view across Wi-Fi technologies and also includes, 5G, etc. It also includes a section on Ldx. So I think some of that information already exists.
But it's in the
but
wrong place, because you're evaluating the Ldx document. And so the Ldx document needs to either reference that over there or replicate enough of it so that when somebody's reading the Ldx document, they know how to put it in the context.
I'm looking at Niels on the camera to see if he has any feedback on that. Does that make sense to you, Niels, or what do you think about that suggestion? First off, can you put that text on the mailing list, please? Because it's evidence of valued discussion.
Right. I'm going to do that. Obviously not because but I will see to it hopefully before the end of the day.
I see Corinna in the queue, who is one of the co-authors, so I think Niels is staying quiet on purpose. Go ahead, Corinna.
Well, I just wanted to say something to it. Yes, that's right. There's a linkage between those two documents. And within our Ldx version, we have a cross-reference to the other document as it was requested and discussed within the different IETFs before. There is a cross-reference completely into these use case stuff.
And it tends to get pulled for other reasons. Say, oh, we really shouldn't put that back in.
You need to be a little bit close to the mic, Bob. Sorry.
I've encountered this before where something gets pulled from a document as you're progressing. And then when you get to the end, you say, oh, we really shouldn't have pulled that. That needs to get maybe put back in.
Valid points. Can you take that to the list, and
the
authors can double check and answer your comments with reference to the actual lines of the document.
Now I'm encountering it in my own work and saying, well, you got to read all these other documents. And they're saying, well, you need to have some text at least here to tell me what to read in those other documents.
Thanks, Bob. Does anyone else have any comment on Ldx? I'm gonna reiterate, please make comments to the mailing list so there is evidence that we have considered and discussed this. I'll add one extra comment sort of targeted towards the ADs, not particularly John, but any others who will be listening to this recording at some later date. I can foresee other documents like this, probably not as long or as complete, about other wireless technologies and how they are applicable within the raw landscape appearing, something about perhaps how to use the ultra low latency 5G capabilities, how to use TSN in an elegant way. Those will still be documents talking about other people's technologies, but will be valid inputs to whatever control plane protocols or other OEM bits and pieces we develop in RAW. So this isn't a unique case as I see it. It just happens to be the first one. So cool. Thank you very much, Niels. I will try and find out what I'm doing with Meet Echo. And Pascal, I think it's over to you if you are online. I can't see you on the list. I hope you're, yeah, he's there. Great. So I'll share the slides and pass the baton to you. Pascal, are you there?
Sorry. Yes. So there's one thing, Rick, is that Lou suggested that, and he was right, that I should have included his words or the discussion that we started on the mailing list in the slides, and I was in the process of doing that, and I'm mostly done, but I'm not fully done. And the new slides with the only difference being the inclusion of what I could after discussion with Lou, they're only on my desk. So the best way for me would be basically to present from my desk, if that's okay.
Yeah, fine. I'll stop sharing. You click the buttons, and I will approve you sharing your screen or whatever I have to do. So go for it.
Okay. So let's do that. So share. So it says, it's sharing slides, but it's not sharing the local
I think you want to
desktop.
share screen if you want to share off your desktop.
Okay. Yeah.
Sorry. Try that.
Wow. So I'm not sure which screen is which screen. It says share screen. It does not indicate what screen that is. Okay, it's not the right one. Bad luck. We're getting there. Yes. Okay, so with this, you should be seeing my slides. Do you see my slides full screen?
Yes, we do.
Okay, so we don't have that much time considering what we need to discuss, thanks to Balázs and Lou, actually, for the most piece, but also due to the discussions that we've been having in the interim, etc. So I will pass the classical introduction to the architecture. Just remember that we are defining a OODA loop where we basically observe and act in order to adapt to the physical condition and mostly of the wireless medium, because that's the wireless which really changes very rapidly versus what we experience traditionally in wire. And so we've done 2 years ago, we decided to split the architecture and the framework, understanding that the architecture is more of what we intend to do and the global kind of scope and broad picture, blueprint, whatever of what we want to do. Whereas the framework is more on how, which techniques we put in place, which draft we develop, etc., etc. So the framework, as we define it, is mostly something that will be available in the end of our project, whereas the architecture is the thing that we need to provide at the beginning of the project to scope it and provide the directions that we're taking. So since the split, we did a number of additions, and we've been discussing since last Ietf whether we are ready for workgroup last call. I think we are mostly ready, and the kind of review I just got from Balázs, for me, is the level of a workgroup last call review. Now, mostly. On the other hand, what we got from Lou needs to be debated a little bit more, and I guess it's pre-workgroup last call. So I'd like ideally to go through both sets of comments, but yes, we need to resolve Lou's issues. The things that change, the things that we've detailed more, and then I'm not 100% sure that this level is the one that Balázs has reviewed effectively, but at the interim, we discussed that we needed to provide more information about how row fits versus upper and lower layers, and how Raw fits within DetNet. So is Raw a piece of DetNet, for instance? Like some new components, some new subsets of DetNet. And effectively, that's how we position Raw. Knowing that at the moment, Raw is rechartering, but was not so far working on the controller plane. And effectively, we hope DetNet will be working on the controller plane, because Raw needs new functions in the new, basically, controller plane function CPFs in DetNet. So we'll be fully within DetNet when DetNet is chartered to work on the CPF as well. For now, we kind of indicate a Raw control sublayer where the PSE stands, and also the interaction with the PCE that will provide the possible subtracks for going around different types of failures. So we basically act in this controller plane, and we act in the service sublayer, where we take actions, for instance, for Pareo, and we also get the result of whatever OAM observes, and we act in the forwarding sublayer, mostly, as users of OAM. So this is the architecture. Now, when you focus on the PSE is mostly in the control sublayer, and well, this is how I see it, but something that we need to debate, because basically the PSE makes decision. It's controlling, and it's the companion of the PCE. So in my view, it makes sense to consider the PSE as control sublayer. Now, the text is not fully homogeneous with that, and even the rewrite that we were discussing for the abstract is not fully homogeneous with that. So we need to agree, and that will be one point of discussion, basically on this structure. It kind of fits within the comments from Balázs. So how do we position within DetNet? So we are within DetNet, but exactly in more details. Do we have PCF, CPF, control plane function? Do we have sublayer, and what do we do in the DetNet service sublayer and in the DetNet forwarding sublayer? So this is the way it's drawn right now in the architecture. And maybe I need to do a pass to make sure that all the text is aligned with this. So would you have some comments on that slide already? Because it's quite important. And I hope it's clear that on the left, the big square is the end system, where Raw makes the ingress of the track, basically. And the box on the right, the relay node, is what we may be doing inside the network if there is a relay, a DetNet relay that supports Raw. In particular, you see on the top right that the PSC could be completely running on the ingress and signaling stuff in the packets that has to be implemented by the Pareo actuator in the relay node. But it could also be distributed optionally so that some more decision could be made along the path. And the architecture allows both models. We mostly discuss the model where the PSC is at the ingress and there is some kind of source route information inside the packet to indicate what to do next. But the architecture is wider than that. You could effectively learn from OAM inside the relay and make decision for the rest of the way inside the relay.
Pascal, we got a couple of people at the queue, so can I pause?
Okay, I don't see them because I'm sharing my screen. So can you please relay the questions to me?
Go ahead, Lou.
Sure. My intent was actually to wait until you sort of went through your material before jumping into the questions that really had been on the list. But you said you want to discuss this now. Am I understanding you correctly, or do you want to?
Well, because we have the material in front of us, I have some of your questions in the slides later. But if we answer them that point now, maybe it's good. I mean, let's fire at will. I think since we are there, yes, please.
Okay, so on this slide, there's two fundamental pieces. I'm going to go with the smaller issue first, and then get to the larger one, and maybe I'll take the larger one after Carlos to give him a chance to, not to hog the queue. So the smaller one, it was a question that I added in this mail from yesterday, which is Paro or the ARQ piece required or not for raw?
Oh, Pareo includes pre-auth, right? It's kind of a superset of pre-auth. And
Yes.
raw, the PSC, for the most piece, controls the Pareo. The Pareo is the act in the OODA loop. The A of the OODA loop is Pareo. So if we, in terms of architecture, Pareo is part of the architecture because we need to say what the PSC does. Now, in terms of definition of the PSC, as you can see on this slide, the PSC is control. The Pareo is service. So you could say, well, in the architecture, it fits. In the whole global raw design, we need to specify it. In terms of components, it doesn't belong to the PSC. It's controlled by the PSC. Does it make sense? Is that your view?
So
And
a
if you
couple
see
of
me
things.
looking left, it's because now I've got Lou on the screen here. That's why you see me looking on the left. Sorry, Lou, but when I look at you, I'm looking left.
I'm actually looking at your slide, so wherever you look, this works for me. It's interesting. You said A is for act. In the document, it says A is for ARQ.
Oh,
So-
I'm sorry, A in OODA. Okay, let's go back to the
A
OODA.
and OODA loop, I agree. But I
Action,
understand OODA.
actually, right? The action in the OODA loop is what the pre-auth Pareo does.
Right, but so just I'm really asking a narrow question. I have a bigger question. I'll get to it. But the more narrow question is the ARQ piece a fundamental component of raw or not? And there's two flavors of that.
Okay,
One-
so no. Let me answer that, please. Okay, so it needs to be abstracted. Effectively, that's one place where you will be very helpful. We don't do ARQ in raw. We signal possibly some desired ARQ behavior to the lower layer. If the lower layer can consume that and do something out of it, it will. If it doesn't care, we cannot pass that information to the lower layer, it won't. But for us, it's kind of an abstract thing. We don't know how the lower layer does ARQ, and we don't do ARQ at the raw layer. It's just some information and that's part of my response to Balázs as well. I think you've got this point in common. How comes that Pareo discusses things that look like to be lower layer? We just hint the type of behavior that we expect. And if the lower layer supports something, supports an API, it's like the L2 triggers, but the other way down. If the lower layer supports that and acts on it, fine. If it does not, too bad. And it's more interesting.
Your answer a lot. I like your answer a lot, and I think I'm completely aligned with it. I don't think that's what the document says.
Okay, let me revise the document in this. I mean, somebody please write that down. But yes, we need. And if it was listed in your latest thing, in the latest mail, I need to answer that. But basically, that's the way I view it. Yeah, if we are in sync, then we need to look at that text and make sure that we say that.
Okay.
I'm just going to step in at this point, Lou. Rather than requesting a change to some specific text, could you suggest some changes to specific text?
Yeah, you're still welcome as an author, Lou. You've been forever, but you're still.
Yeah.
So sure, we'll see what happens. I actually have more substantive comments. I'm going to wait until Carlos. If that's okay.
Sure.
And then if
join the back of the queue.
Yeah.
Hello,
So, Carlos Bernardo, usually Ren. Hi, Pascal. Yes, I have just a kind of a request that I think for me, maybe for other people, it will be helpful exercise to try to do an example of how this architecture view will work, like with actual, end nodes, a flow, and how that will, what type of interactions that will imply in a what I would call pure raw scenario, and what I would call a raw plus DevNet scenario, which may have implications also on the multi-domain thing, because we can consider DetNet, pure DetNet wire scenario as one domain and a more wireless raw scenario as another domain. But for me, it will be very useful exercise, and I think it may help other people and the discussion to have that type of example.
So do you mean in terms of some sort of signaling sequence diagram?
Yes.
Or kind of
Yeah,
interaction?
so we can see basically the functions that Pascal put there, how they interact between each other, among each other, and we can see the actual data flow and control flow. As an
So
example.
there are a number of drawings already in the document. Maybe we can build on that to achieve what you want. Some of them were there for a while. Some of them are very new. And so when we go through those drawings, maybe I can, ask you if that's a good start for what you want to achieve, or if what you want to achieve is completely new versus what we already have. In both cases, I'm completely open. Yeah, that I don't want to go too far, because if we give too much details, we are in the framework world, right? And if maybe what you want, we should start writing it in the framework, but not the architecture. We need to express basically the boxes and the flows, how things interact. We don't want to go into too much details of how that happens.
Yeah, well, Pascal, just to clarify, for me, these diagrams, I don't care at this point where they go. It's just an exercise for us to go, to progress, and then we can discuss whether this should go in one document or other document. But I think it's useful for us to progress on this exercise.
I'm just going to jump in at the same point, and I agree with Carlos on this. I think having those diagrams is important. Whether they go in this document or the framework is a secondary matter, but I think it gives us some scope for clear understanding of as we progress. A point of order. Pascal, do you want to take more questions now? And Janos, is your question about this particular slide, or is it a more general one? Because I think Lou's question is more general.
Yeah, I had a similar question like Lou's, like, do we want to have the open mic discussion now? I have related comments and more generic ones.
So Pascal, what would you like to do? Continue?
Well,
and then
that was Lou's big command. And I think we need to hear it, because Lou has been very polite to go to the end of the queue. And then, if you think, I'll take it, it's going to be your choice. If you think that this slide that we're presenting is the one that fits your discussion, then let's take it. Otherwise, maybe we can hold it till we have a better slide for it.
Yeah, I haven't looked through your package, so I don't know which slide is best, but it's a general comment about, my comment is an architectural, and like Janos, or I shouldn't say architecture, more fundamental, is you're defining a whole lot of new terminology for things that already exist in the IETF. And, Rick said at the beginning, one of the things we want to do in our reviews is try not to invent new terminology and new things for stuff we already do. And I feel like we're doing that in the architecture. And that's the discussion I want to have. I really would feel more comfortable if we do that at the end.
Yeah.
So that you have
an opportunity. That one, I have a slide from your comments, typically on the TE thing. So I have that slide, and that's really one of the reasons why I'm presenting from my desk as opposed to the package that's already there. Because, you basically hinted me that I should have done that like yesterday. And then there was a lot in my plate since then. So I was not finished to be able to push it in time for to be captured.
So Pascal, let's keep going through your slide deck, and we'll take these sort of general purpose comments at the end then.
Okay. So this is a picture that is newer, right? And this is also a discussion that we had at the interim, is how does Raw fit within DetNet? And if you remember, we've got two major use cases. One where we've got DetNet service end-to-end, and Raw just integrates with that, in which case we do the control and our additions to the DetNet services, basically. And if we ignore that, we do some special stuff in OAM, and we agree that maybe the OAM is completely part of DetNet, and whatever we do is retrofit in DetNet. Then we can really abstract this as end-to-end DetNet services, scattered Raw plus DetNet, DetNet forwarding end-to-end, DetNet services in some nodes which are called relays, and in those relays we expect Raw as well, and then Raw control maybe only at the egress, or possibly also optionally at the relays. if the PSE is distributed. So this is one model. That's the one that we use, for instance, in the case of a mesh, where we build what we call a track, and then for which there is this discussion about terminology. So that's one model, and that's the most classical model, I would say. Now, there is another model that we didn't have at the beginning, but a number of people insisted that we work on it. It's the model where Raw mostly controls the RAN. And the RAN, by RAN, I mean the radio access network, Wi-Fi. And there was a picture by Balash, actually, in just the email he sent 2 days ago, where you can see the device, like the user equipment or something, doing 5G or doing Wi-Fi, and possibly, if it's a robot, having a fiber as well, and deciding which network it's going to use. And depending on the access that it's using, .NET may be available end-to-end, might be available, .NET forwarding, I mean, might be available only all the way to the end of the 5G network, but not across the internet to the application, which is more like this picture, or could be just not there. And so if it's not there, then, or not end-to-end, then we cannot provide end-to-end guarantees. And at least for timeliness and time latency guarantees, we cannot provide them, because we really depend on .NET and lower layers to provide timeliness, basically. In that case, Raw is still useful, because Raw can do end-to-end OEM, between the ingress end system and the egress end system, and measure whatever it sees depending on which access network it's using, do replication across Wi-Fi, 5G, whatever is needed. And if it finds that using 2 Wi-Fi interfaces is enough and 5G is expensive, or on the contrary, 5G is so much more reliable that we could shut all the other interfaces, I don't know, then it's going to be the PSC making that decision and using only the relevant network. So in that case, the PSC is still useful, even if we don't have .NET end-to-end. This is, like I said, the access use case, and we have it in our prime statement. And so for now, we still support it. In that case, we still see our design as within .NET, but it's not with .NET end-to-end service. And so we don't have latency guarantees. There are more subtle variations which are not illustrated in the architecture, and so I drew them. It's up to you guys to tell me if we want them in the document as well. But for instance, there is the case where, and it relates to our transport discussion, where there is some UNI interface between the .NET Edge node and the end system. We don't have .NET forwarding. We might have TSN, or it's just that the link layer provides enough guarantees in terms of latency, etc. between, for instance, it's 10 gig and we have limited traffic. So we have good enough forwarding between the end system and the first hop .NET Edge node. And the traffic is basically controlled just through the UNI, and it's not basically what we currently have defined, but the .NET architecture allows for this. So in the future, we could define the UNI interface that is enough for the .NET Edge node to control the end system. And so this is a variation where we can still get guarantees across, all the way to the end of whatever .NET forwarding supports. If there is an internet piece, then there is no guarantee end-to-end. If the internet on the right is just the access, then we can still provide guarantees. So basically, if that picture is symmetrical. So I don't know if it makes sense to add this picture. I'm willing to add it if you tell me to do that. It's a variation of the previous ones. So there is also new text on the dependencies. So I highlighted what I think is the most important in the new text. Important is Raw is not in the forwarding sublayer. So we don't provide, or below. So we don't provide guarantees like latency. It comes from a good interaction between the transport layer above us or the application, whatever provides the packet, and how the source of packet above us, transport application, respects the contract that we have with the DetNet layers, and basically DetNet forwarding and lower layers, which basically can consume that traffic, when it's being passed, and forwarding it down the end-to-end across the DetNet forwarding plane. So Raw does not play a role in that. Raw acts
Pascal,
for the distribution. Sorry, yeah.
Can I just quickly interrupt? Balázs has
Please.
a clarifying question, so I thought
Okay,
I'd just address
please.
Go ahead,
Yeah.
Balázs.
Hi, Pascal. Balázs Varga from Ericsson.
Yeah, Balázs.
Can you go back one slide?
I sure can.
Yeah. So just for understanding, so I am somewhat confused with your term uni access. We have here.
Oh, uni is uni and access is the link. So the two terms seem to go together, but it's a UNI over an access link. I just did not have enough space.
Okay, I am also concerned about the UNI, because here we have end-to-end DetNet. So also the end system, they are speaking DetNet. So why you are calling edge node, the DetNet only service node? It should be a relay node, and the end system is DetNet aware.
No. Let's take that offline and look at the DetNet architecture together to make sure we speak, of the same things. But DetNet basically has end-to-end servers. It has end systems, and it has ingress and egress edge nodes, which are not necessarily the end systems. And so, the UNI is when the ingress edge is effectively not the edge system. So for instance, if the edge system is a PC, and this PC is not capable of DetNet, but the first switch is, or the first router over the access, the one hop device is, then the UNI interface is basically how the PC will negotiate the creation of a path, for instance, how when the path is installed, the PC will know, and also whatever pacing method is done between DetNet and the PC, so the PC provides the packets in due time. So all this is the UNI.
Sorry,
okay,
Pascal.
let's continue offline. I think this is a longer discussion.
Yeah, it's a longer discussion. It was envisioned in the DetNet architecture. We have not worked on it. But if you look at the DetNet picture, you will find this. I mean, this has been like from the inception of the working group.
Okay, can we? Do you want to continue? And we'll take that discussion to the list, or continue it at the end, if that's okay.
Yeah. So let's go. So Balázs, since you're there, right? So I just noted your three questions and what I answered on the mailing list. So I know it's a lot of text, but it is because I just copied paste basically the question and answer, and I answered on the mailing list as well, so we could prepare for the discussion. And this is very related to the point that Lou just made. And so my answer to Lou stands, and I think that's what I wanted to write down here. And I would like to see if we are in sync or not in sync. So did you have a chance to read my answer already, or Balázs? Or I mean, maybe you can stay at the mic actually, because it's your 3 points coming in a row now.
Yeah. Okay. So I have already read your answer. I do not fully agree with that, but based on your presentation, I think that you are not defining, for example, with Pareo, a data plane functionality, but only a controller for those data plane functionalities. So maybe that would work for some further discussion.
Yeah, we can improve the text on Pareo. The first step would be to make sure that we are in sync on the intention, and then we can review the text to make sure that it fits that intention. I understood that Lou and we have the same view, and that view is what I tried to write here. And basically, L3 is always working on abstraction of L2. I mean, that's what it is. It is an abstraction of L2. Now, because radios are very dynamic, we need to add dynamic state or information or control in this abstraction. And Pareo, the difference between Pareo and pre-auth is pretty much that we signal that, those dynamic things. And that can be in one direction to triggers like receive signal strength, link quality, ETX. In the other direction, it could be, please try to do as many retries. Please send it as a MAC layer multicast, so there will be more than one node receiving it. And that's basically what we call the overhearing in the O of Pareo. It's basically controlling the fact that instead of sending unicast, you send multicast, and the receivers that expect the packet will be listening to the multicast packet.
Okay, so from my side, most of the confusion is coming from the fact that you are stating in the document that pre-auth is Pareo, or better to say, Pareo is a superset of pre-auth and other functions. But
yeah, that's
now based on our discussion, I tend to think that what you intend to say is that Pareo is a control function which is controlling those functionalities and not replacing and owning.
Oh yeah, I mean, for the most piece, Pareo, for the command letters, I mean, Pareo is exactly pre-auth. Now it just has more letters in it, and some of those more letters is a way to control lower layers, or at least hint the lower layers. But yes, I mean, the P is the same P as pre-auth. It means the same thing exactly.
I'm just going to draw a line on that conversation and say, can you take that one to the list? Because I've got Janosch in the queue. I know Lou wanted a few comments, and I'm watching the clock here. Good discussion. Please take that one to the list, because I think it will need some careful wording.
So do you have?
Go on, Janosch. Sorry, Pascal. Hold on 1 second.
Janosch Farkas, affiliated with Ericsson. I just wanted to add one piece on this, like what you said verbally. I had the same confusion, like Balázs, and what you said verbally was more helpful for me than the email list and everything I've been following. I really had a thorough review of the document, tried to follow the emails, and I think the API is a key. It is not there in the document. And the two-direction aspect of the API you just explained is key. And as for the term Pareo itself, looks like layer violation on its own, like combining the two, like the arc or hark belongs to the lower layer.
Yeah, it's arc control, it's not the arc itself.
And maybe it's not so good idea to combine those.
No, it's not the idea. The idea is to combine the control. Yeah.
And also the modeling of the lower layer or the radio layer, which was the part of the comments in the email conversation. I think it's kind of crucial, because the document says that Raw is agnostic, but actually that's not really how it plays out. So we have to be careful when we specify the API to really be agnostic and allow the different kind of models, the different.
Yes, it is agnostic in that it abstracts, right? So you have to expect abstracted features which may or may not be there. It's not, we don't know exactly if a certain lower layer will do it, but we can ask for it. Okay. Lou?
Lou Berger. I'm glad I waited, because I had two fundamental points, and Janosch just made the second one much more eloquently than I could. The fundamental point is that the document reads as if all the elements described related to Pareo are being done by Raw, as opposed to being controlled by Raw and being done by a lower layer technology. That's really not clear in the architecture, and that's a huge fundamental point. So I just wanted to reiterate. Thanks.
That one is taken, and certainly we'll act on it. I hope the minutes reflected, but it will be very difficult for me to think.
So I'm going to join the queue here. So this is partially chair hat on and partially me personally. I think there is a way forwards here. What I'm sensing from the discussion at the moment is the sentiments in the text are great, but lack a certain level of clarity, where Carlos is saying some really good diagrams would help draw out the discussion. I'm hearing people saying, Pascal, you're being very clear when you're answering the questions, but somehow that clarity is missing from the document. So I don't have a good proposal on how to get that clarity, but I think there needs to be more work on this document. And I'm kind of looking at the people such as Janusz and Carlos and Lou to drive a little bit, to assist Pascal, who, you know what it's like when you write your own document, you understand implicitly what you've put down because you wrote it. But as an outsider, digging through other people's language can be a little harder. So I think some of the work here has to be done by the commenters to say, actually, I have redrawn, or I have drawn a diagram based on my understanding of your text. Is this correct? And that can then become,
which is a bit what Balázs has done
a
already.
pairing diagram or whatever. So
yeah, that's very useful. Yep.
Okay. So Pascal, we have about 5 more minutes before we eat into everybody else's presentation time.
Oops. So we need to move on. So modeling of radio components, I think we've discussed that. I was not sure, Pash, what you meant by it's not the way the lower layer do it. If you meant the 5G networks, which appears as a virtual switch, in that case, completely opaque to us. Now, my suggestion was to improve the discussion on the interaction with the lower layers, which is exactly what we have been discussing here. We have a dependency section. We could also describe, that dependency, the APIs or something, and the fact that Pareo controls the ARQ and the overhearing functions, but does not do them. Just like DetNet expects the lower layer shapers or something, but that does not do them.
Just a very fast feedback. So it is not a virtual switch; it is a router in latent discussion. But I will comment it on the list.
Okay. So I thought you were doing TSN only, but okay. So related to Q1. So you seem to be seeing an opposition with the non-row subnetwork can be neglected. So I don't know how to word this, and then again, I can use some help. But this was referring to this picture early on, where a set of the network is not controlled by DetNet, the piece that we kind of call the internet. And the way we operate in that case is we measure the end-to-end OAM, basically, and whatever happens, whatever price we have to pay is built on the first hop of the access. So basically, we do as if the access was responsible for all the latency, was responsible for all the jitter, was responsible for all the hops, all the loss, even though they are only observed end-to-end, and it could be buffer bloat in the internet, it could be congestion loss in the internet, etc. But since we don't have that net end-to-end to guarantee that the service will be fair, will be correct all the way down, we can only say we need to select an access interface. Let's select the access interface that provides the best end-to-end result. So that's what we had in mind in that the non-row subnetwork can be neglected in the computation. We can write it some other way, but that was the intention. So what is the confusion, or maybe we can continue on the email because we are late. But basically, yeah, I'm happy to clarify. I just don't exactly understand what I should be doing. So loose cables, and that's the slides. I had sent an update, but I was missing one, so I will send you another update, Rick, after the meeting, so you can push the latest slide on the repo. But so one of Lou's points was the term row, and we already discussed that at the in-train last time. And basically, what is row? And another way of doing this is asking this is row the OODA loop, or will there be more? Because today the architecture is the OODA loop, right? It describes the OODA loop and provides more information about the PSC because it does not exist, but we also provide information about Pareo, etc. Because we are defining the whole OODA loop, including OAM, etc. for observe. And question is this OODA loop row, everything about row and only row? Or is this I'm sorry. Pardon, je dois vous rappeler, je suis en conférence, je parle en ce moment. Désolé, je vous rappelle. Sorry, I was called twice. I had to tell the guy that I will call back. So basically, for me, if Raw does not recharter ever, Raw is the UDA, and Raw is basically what we have in this document. On the other hand, if some people consider that Raw will recharter, work on other stuff which are related to wireless and make it more reliable, available some other ways, then maybe the name of this document is not correct. It's not the Raw architecture, it's the Raw UDA architecture or something. So that's basically my answer to Lou, and taking hints there. Whatever you guys suggest.
I'm gonna jump in the queue myself now, and then Lou can have a go. This is Rick here. Hat off. I understand the reference to UDA, and this is actually going back to a comment Carsten made in the chat here. Yes, UDA is a great fundamental, but I think we're all fairly familiar with the fact that this is a control loop. We are making a decision, receiving feedback on what is occurring as a result of that decision, and updating that decision. And in a wireless dynamic network, that is required. Some could say that in a fixed wired net environment, that complete loop is not needed. You can make a plan and push it down. Lou is shaking his head saying, actually, you do need that loop anyway.
Yeah, it could be useful. That's one of Lou's questions as well. Why restrict it? We are abstract, we are layer 3, we should not restrict anything. That's my answer to Lou on that particular question.
So
but it's certainly more needed usually on wireless than it is on wire, but it should not be restricted.
I don't think we need to spend a lot of time talking about UDA, and I don't think UDA defines RAW. RAW is about extending DetNet to work with wireless, and that requires a feedback loop.
Yeah, so should this document is limited right now to UDA. That's the only thing it discusses. So maybe in the future we'll be doing more stuff. In this case, but more stuff, how will we call it? Because this architecture document is limited to the UDA. So my question is, if RAW is more than the UDA, then this document is probably not the RAW architecture, it's the RAW UDA architecture. So just the UDA piece of whatever RAW is. You see my point?
Yeah, it's a little philosophical for me, I think. So yeah, I'll step out of the line and let Lou speak because I'm watching the clock.
So I now want to react to the conversation that just happened. Sluberger, UDA is a philosophical definition, or it's a high-level definition of reacting, and all of our control protocols follow an UDA loop. So saying UDA loop is novel here, I don't get it. But
we're not saying it's novel. We're just saying that's what we define. We define a UDA loop.
I think almost every control plane protocol that we have in the IETF follows an UDA loop. So it doesn't, to me, it doesn't add a whole lot to use the term UDA, but it doesn't also, it's like, okay, sure, I accept it, but I don't think it's something fundamental to RAW. I don't think it's fundamental to the document. Frankly, I don't think it adds a lot, but I also don't think it hurts. So, but if you're saying this is only the raw UDA architecture, I don't understand the difference between the raw architecture and the raw UDA architecture. But it's a philosophical thing.
I don't know either, because right now that's the only thing we've discussed. And is there something else completely different that layer 3 .NET could be doing for wireless, which is not this control loop? I don't know.
So rather than go to the philosophy and rather than talk a lot about it, I think we should be focused on what the text actually says and the updates that we need to the text. Because when we have these discussions, I think we are largely in agreement about high-level concepts, like the whole discussion about the layering, but it's the thing that's lacking is the translation of the discussion into the text. So rather than talking more about the high level and worrying about that, I think we really should be worried about the sections of the text that are problematic.
Yeah, and we need to do that on the email, but completely agree. I'm fine with that. Yes, please help.
Just an additional comment on what is RAW, and I could not articulate this before your presentation helped, and the figures like showing raw service and .NET service. And I'm not sure that we are making a service to the industry by distinguishing these two. Like even the text on this on the slide copied from the architecture was like, my view was that for layer 3 like IP, there is end-to-end one service like a connectivity which we used to call .NET service. And I thought that what we are doing in the Raw group is defining the wireless segment, the wireless subnet segment on how to achieve this end-to-end deterministic service. And if we now, like, we introduce a third one, like we have TSN service for the TSN subnet for layer 2, and we have the .NET service as defined by the .NET working group. If we keep adding on, which is essentially the same, just over wireless.
We are not creating a .NET service, right? We have .NET functionality inside. I'm sorry, we have raw functionality inside the .NET service, and I hope that there will be a .NET control sublayer, so I can change this picture to say that the PSE is part of the .NET control sublayer, which is, I hope, what we'll be defining soon. Right now, since it's not there in the architecture, I had to write raw control sublayer because there is not such a thing in the .NET architecture. But otherwise, what this picture wanted to make clear is that whatever we do is components that fit inside the bigger set that is called .NET Service and .NET Forwarding. Right? It's not a new service. So it might be this picture actually which is distressful. Well, let me go back to the next slide.
When again, I like what you say verbally, and somehow we need to update the pictures, figures, and the text.
If that's this picture, the raw plus, I didn't have much space to write, but it's raw inside, .NET service with raw stuff inside. That was the intention.
I'm going to conclude this now because we're running out of time, but this is useful, very useful, and we need to take it to the mailing list. I'm going to make one last comment about, is raw OODA or is raw bigger than OODA? And I'm going to do it in reference to the charter. We have been chartered for 12 to 18 months, and we've already taken 2.5 years. I would suggest that the OODA loop and that traditional reactive control plane feedback loop is what we were chartered to work on as raw. If there is some exciting new way of doing it using machine learning and predictive modeling or whatever, that would be another working group. It would definitely be a rechartering. So I'm looking at my AD to tell me I'm wrong, and I'm looking at my co-chair to tell me I'm wrong, but I think we do OODA. That's enough for us now, and I don't.
So let's keep what we have. Then we are writing the raw architecture, and there is no need to change anything, the title or anything. That's what I was asking.
That discussion for now, and let's have a barb off about whether we want to do something else. But
okay, so is it the end of my time? And so we skip what I had left.
Pascal, thank you very much. Let's take all these good conversations to the list. We will continue to have virtual interims so that we can continue to have this discussion.
Yeah, so I'll keep the slides for the next interim, and I really thank you for all this discussion. I'm looking forward, for help in getting things written the right way. So at least we seem to be in sync on the intention, and that's great. I mean, we are not that far. That means we are not that far.
So Eve, I've lost track of the agenda because I lost my DNS for some reason. So I think it's Carlos next, isn't it?
Yes, it's Carlos. And I guess, Carlos, if you wouldn't mind, we are needing we've assigned, you have 2 talks for 15 minutes.
I beg your pardon, Eve. It's
Jerome. Jerome for 15 minutes. Yeah. Okay. And then Carlos follows with 2 talks that maybe we can press down by a couple of minutes. Okay.
So Jerome, I'm going to share your slides and pass you control. So if you've not done it before, if you hover your mouse at the bottom of the screen, a little semi-transparent bar pops up and you can step through your own slides, if that's okay. Otherwise, go ahead. Sorry for the delay. Audio check. Hello, hello. Jerome, can you hear me? We don't hear you, Jerome. Still can't hear you. I shall unshare his slides and see if he notices. Jerome,
Oh, yeah.
we can't
Happy
hear
hearing
you.
us.
Jerome, do you want to do an audio check? Just check your audio is working. Or it appears to be at my end, it might be the problem, but
No, it's also on the internet.
Jerome, we can
And Jerome,
see.
perhaps if you stop doing video, let's try that as well.
Or do I have to give him permission to speak? No?
No, he's open mic.
Everybody can speak.
I think it's a local problem, yeah.
No, it's
Echo,
also.
can we have assistance, please?
Are you hearing me speak?
Yes.
Yeah, we're hearing you, Eve.
Oh, okay. So it's not a local problem. And of course, Carsten is also remote. So perhaps it is Jerome's problem.
Rick, can you share something on the screen saying that we can't hear you, Jerome? Like if.
Yeah, he can't hear us, can he?
I think that may be the problem as well. Jerome, are you using the right set of headphones? I do that regularly, mixing up my headphones.
Did we just lose Jerome altogether? Yeah, I think he's just.
Yeah, maybe he's coming back in. Maybe what we do, since we are pressed for time, maybe we jump to Carlos and we will come back to Jerome. Okay.
I'm trying a different browser, sorry. Apologize.
That's quite all right. That's
Jerome
great.
is
You're
here.
back, Jerome. We'll jump back to you. Sorry, Carlos.
I'm very sorry. I thought everything was working until I tried.
Does not matter. It is always the way these happen. Okay,
I'll
cool. You've got.
I'll go 2 minutes shorter to take up for the time. Thank you very much for the opportunity. So, so there's a lot of things going on into 8.11 that may be of interest to us. A quick reminder first on how things are articulated over there. You know, there is the main 8.11 working group at the IEEE, which has amendments which are developed every often. Each of them has a letter sequence. We've done all the A's already and all the alphabets. So we are in BE, BF, BEJ, etc. And then on the other side, there is the Wi-Fi Alliance, which has certification programs. There are a group of companies that go together, select subsets of what the IEEE does, and create programs that people certify against. So all companies have a backward compatibility with each other. The programs that are typically making a lot of noise are those that improve performances, and those bear the name Wi-Fi plus something. We are at generation 7, so you may have heard of a Wi-Fi 6. That's probably what you have at home, which is a set of certification that implement a standard, which is 802.11ax. So in the IEEE right now, we are in the next generation, which is 802.11be. This amendment will have still a few years to go. It's slated to finish by 2024, beginning of 2024. Which seems long, but we're discussing of scale. We have about the same scale structure at the IEEE, where most of the work is done now. They have to make sure they tighten all the knots and all the bolts, and that takes typically a year and a half. So it's pretty crystallized what's going to be in BE, and the Wi-Fi Alliance has started a group called Wi-Fi 7 that is going to certify several elements of it. The reason why I mentioned this is because in 11BE, there is a new feature which is called MLO, which is multi-link operation, by which you see the illustration at the bottom. A device, typically a station, can create 2 links, 2 connections to an access point, and have a single identity over these 2 links, which allows, of course, a better reliability. The initial days of MLO were creating the intention of allowing this mechanism across multiple access points. But they realized that that implied a lot of coordination requirements between access points, and there was a lot of complexity, and they realized they would not have time within the time imparted to BE to finish that. So they parked that. So in 11BE, MLO functions against one single access point, two radios, for example, 5 gigahertz and 2.4 or 6 gigahertz. So that increased the reliability of operations on one side. There are plenty of other things in BE and previous generations that are very targeted toward better reliability. Among other things in BE, there is what they call uplink OFDMA, which essentially allows an access point to schedule uplink traffic from multiple stations at the same time, and allocating some slots for these stations. This can be part of a negotiation between the station and the access point, which makes the process very reliable in terms of providing the station bandwidth at the time it needs for the need. The mechanism is still congestion based, so it's not purely controlled, but it's much better than what we had before. So BE has done a lot of good things, but things are left to be solved. In particular, this MLO structure against multiple access points is something that was left for what I'm going to call 802.11 generation 8. So that's going to be 802.11b something Z, X, Y, depending on where they land, where this group is formed. But that's the next generation after BE that will have to address this coordination between access points for MLO. And that's, of course, very important for us, because if you have a device that moves, you want not only to have better reliability into one access point, but also make before break, so create a connection to the next AP. So you already have a connection as you move from one access point to the other. In short, you have zero delay in the roaming and zero loss. So that's the goal. In parallel, three things are happening that may be of interest for this group. One of them is that they realize that many IoT devices start connecting to Wi-Fi, and several of them are battery operated. And the idea is to maintain the battery as long as we can. So there's a new group that was formed in July, this month, a couple of weeks ago, that is called AMP, Ambient Power. And the goal is to be able to harvest energy from the environment to do two things. One is recharge a battery if you have an operated battery device, but also use this ambient energy to reflect back energy to a system, which is somehow very similar to what you have in stores with this anti-theft system, where there's a sort of coil that radiates back energy from the gate, and that allows the system to detect that something is being taken out of the store. This is important for us because, of course, harvesting energy from the environment is good. Introducing systems on the same frequency that are going to be radiating back energy for other purposes might create some difficulties in coexistence with Wi-Fi devices. So everybody's keeping a very close eye on what exactly this AMP group is going to be doing, just harvesting energy, or also introducing noise, so to speak, in the Wi-Fi world. Another one is something which is probably derived from the 6G initiative, where machine learning is being introduced as being a very important component. So here as well, there is the idea that optimization and reliability in Wi-Fi is only going to happen if there is smartness in the coordination between the access points and the stations. So in July as well, another group was formed, which is called AIML, which is essentially artificial intelligence and machine learning for Wi-Fi. And the goal here is to examine how each side can use machine learning tools to improve the conditions of the cell, so that implies reliability for us, but also exchange between the client and the access point on machine learning things. And here we think of metrics and statistics, so that one side can do better computation, or exchanging previsions and predictions and models. So that's two groups that are very interesting. Another one which I think is useful for this one, for this group here, is not created yet. It's a group that is likely to be created because it was approved. Its creation was approved in July. And that's what is called Ultra High Reliability Study Group. So in the Wi-Fi nomenclature, we have 802.11 nomenclature, we have typically first a topic interested group, TIG, where people discuss whether a topic is of interest to enough people that we want to dig further. If the conclusion is yes, then we create a study group that studies exactly what could be done there in 802.11. That typically lasts for about a year. And at the end of the SG, a task group is created to actually do work. So here, improving on Wi-Fi condition is so obvious that they didn't have the need to create a TIG. They created directly a study group. That's going, again, to be created in September. It was approved in July. And you see the list of target areas here. So this MLO between access point is likely to be taken by this group as well. But you see on the list, they are going to work on many items which are going to be of interest to us. So, if anybody here is interested in those topics, please, reach out to the IEEE. It's like the IETF, it's individual driven organization. We also have liaisons and all these things so that we can continue exchanging and see if there's anything in 8.11 that this group in particular can do that could be of interest to Raw. For your reference, I added a few links to IEEE. As you know, all the documents are publicly available. So those are a few documents that may be of interest for our conversation. Let me pause there so I don't take any much more time. I'm very happy to answer questions if there are any, or pass the ball to Carlos.
Thank you very much, Jerome. There's no one actively in the queue at the moment. For time purposes, can you take your questions to the list for Jerome?
Absolutely. Thank you very much, everyone.
Really useful material. Thank you. Go ahead, Carlos.
Okay, Carlos Bernardo from UCDM. I think for the use cases, we can even skip the slides because the summary is very short. We didn't do any updates since last ITF because we were in the publications process, and well, we discussed before that it will be. So basically, just to report that the authors are ready to tackle any comment that results from that the AG evaluation and the Sephardin process. So we can jump to the next one, and then we save some time.
No worries. So quick nudge to our AD. That document's been waiting in the ISG review queue for a couple of months now.
Yep. So this is part of my mea culpa email that I sent out to at least my chairs earlier this week, which is, yes, I'm behind on my queue and I am working to move things along faster. Thank you for your efforts. I'm trying to match them.
Thanks. And then the raw multi-domain, that's a work that is ongoing and that we will have also a kind of separate, more high-level discussion in DEDNet tomorrow. So next slide, please. So the idea here is that in the working group, we have been mostly focusing on single domain. At least we didn't touch specifically multi-domain aspects, although this discussion that we had with Pascal before about the raw and DEDNet, to me, that's part of the multi-domain aspects that we need to tackle because technologies may be considered different domains. So we justify or we motivate in the document that there are different scenarios in raw that require of multiple domains. Again, meaning domain, something that is a technology or an administrative domain or both things. We may have different technologies and administrative domains. And the idea of this draft is to motivate, and this will already fulfill that purpose, the discussion on what are the potential gaps, if any, that needs to be tackled for multi-domain. Maybe the conclusion is that everything is supported, fine. In terms of architecture, OIM mechanisms, control plane mechanisms, and if something is needed, maybe explore potential solutions. In this particular document, there is a kind of solution sketch, but the main goal is to motivate the discussion on the gaps, not to actually discuss the solution yet. Next slide, please. So this is an exemplary scenario. We have two different domains in the slide, each with its own PCE, and there are kind of multiple potential gaps that we need to tackle. On the one hand, we need these two domains to discover and set up an interconnection that may be done with a different solution or maybe already in place. And even with that connectivity in place, we will need to, for example, have inter-PCE work. There are documents in the IETF for inter-PCE. So the idea is to check if what is there is sufficient or not for raw DEDNet purposes. And then check if we need to have some inter-domain PSE coordination or API to support this scenario. Again, this is ongoing discussion. The document is proposing a solution in the next slide that I will not go into the details because this is just as please go to the next one.
Oh, sorry.
a potential solution. But again, the idea here is to discuss on the gaps. So we can go to the next one, which is the last, if I'm not wrong. So the idea is there any interest in looking into this? Again, looking into whether this is a problem or not. If this is a problem, then we can discuss whether there are solutions that can be done in IETF and in which working group. This is related to .NET, and actually in .NET, we have a companion document looking more at the high level and the .NET level, trying to explore the gaps. And I also benefit from the opportunity that to mention that we are going to have a EU project funded that is very much tackling into these points and also into what Jerome presented about the use of AI to predict in a .NET Raw environment. So maybe that we can bring more content related to that into .NET and Raw. And well, the idea is to get feedback. Do you think, guys, that this is a relevant problem to work? We will have discussion tomorrow on .NET as well. And if so, please join us to continue working on the document.
Thank you, Carlos. Personally, I think this is really important work. I think you can't just have a single domain solution and expect it to work everywhere. I, with my chair hat on, would like to be led by work happening in .NET and build on it to make it work in a raw environment. I think that's the best way to work on it. And I'm looking at Lou at the mic. Let's keep it snappy, but yeah.
Yeah, I'm going to agree with everything you just said. I think if we clean up the architecture, it'll actually help because, for example, the inter-PSC, we already have cross-domain protection mechanisms in the larger TE body of work that we can just leverage.
Perfect. Thank you very much, Carlos. Bob, thank you for being patient. You almost have your full time, so well done everyone else for going quick.
Okay, got to bring this down to my height here. Okay, get my slides going here. Thank you.
And you're up.
Okay, please proceed. Why am I here? Why am I doing this? Because bad things happen to IP datagrams in the internet. They tend to get lost or trashed. RED is real. I was in the meeting room when RED was designed. It is called best effort for a reason. I worked in 802.11, 802.15. Wireless links are amazing that they work as well as they do. But there are times when the mail must go through. Segue here to a picture of a mailman going through a blinding snowstorm. Don't expect the internet to fix your problems. Yes, we're here in Raw and everything else.
Is your mic still working, Bob?
Don't expect the internet to fix your problems. It works well for everything else, so why worry? Amazing things can be done over wireless links. What are you willing and able to pay? Fast, reliable, cheap. Choose two, or maybe only one. And it's a smart or dumb internet. We can do better smart things with a dumb internet. It's cheaper for the internet if we don't put this in the internet, and pricier at the endpoints. In the applications, cheaper but never ending. Close to AP is better, but how can you change the stack? And sometimes we do need to fix things in the internet, make it smarter, like RED. We designed RED one day during the day, and we pushed it out that night. It was that fast because we needed it. What I'm proposing is a simple proposal, and that is provide at the IP datagram level forward error correction. You compute the FEC on the datagram, chop it into pieces, minimally 3 pieces, 2 for the datagram, 1 for the FEC, and send these multiple pieces, and then reconstruct the datagram from the pieces received, and you have your message. You have a high reliability on a low reliability network. Take advantage of a technology that's been around since 1960 and apply it here at the IP datagram level. The IP datagram level to limit the total data sent. Yes, we can do this above transport. We can do this in the application, but then we'll end up having more data, more chance loss. Do it at the IP datagram level, and I think better things can be accomplished as a result and can manage the costs on the constrained links. So here's an example. It's a very simple example. Things that we've done with Reed-Solomon. Reed-Solomon was created back in 1960. So IP datagram is n bytes long, and make it even for simplicity. And the fact thus is n divided by 2 bytes. So each datagram is 40 bytes for the IP header plus n divided by 2 bytes. So your total is 120 plus 3n over 2 is what you set to get the message across. Note that it's cheaper to send the packet twice if your IP datagram is less than 80 bytes long. If the IP is only long, just send it, achieve your reliability by sending the message twice. And there are smarter texts out there and other ways to do it. If you have a low reliability, you may break the message into 5 pieces and have 3 FEC frames interspersed between to get the recovery. The beauty of this approach, it's end-to-end. There is no global FEC defined, no mandatory to implement. What is your reliability you're trying to achieve between those parties? That's the FEC you use, and it can be dynamic. You can change the FEC based on what you're experiencing, when you're experiencing it, or how critical that mail is to get through. Next. But how to do this? How to add FEC? And this is where Sheik comes to the rescue. Apply Sheik rules to the IP datagram, then apply FEC and send with Sheik as the IP protocol next header. See my presentation this afternoon in the LPWAN about this subject. Use the Sheik rule ID to encode the block number, lower 2 bits if there's only 4 packets, and then apply signals in Sheik on needing must deliver. So the application says this must be, use the Sheik rule, and Sheik does the FEC, comes to the other side, the Sheik module then does the reassembly, and then passes a proper transport layer. So there's a way we can do this if we provide Sheik as a, and see my presentation this afternoon. Next. Ta-da! It's easy to implement and to test to prove, because we don't need infrastructure to test to prove this. In fact, it'd be good if we don't have infrastructure and we have bad links that we're testing it over. The endpoints do need Sheik support. The internet needs to respect Sheik as an IP protocol number. That may be a hard one. Hopefully not just dropping it because it's a new IP protocol number. And select the FEC, which will work, plug it into Sheik, and we need some help here to do this sort of thing. And then run tests over questionably reliable links and measure the success improvements. So it would not be a long stretch of work to say, does applying forward error correction at the IP datagram level increase our reliability of delivery of important messages, regardless of what the wireless link may be doing? Of course, the wireless link down, forget that. The wireless link will be doing, or what Red may be doing in your environment. And so, next. Thank you. Are there any questions? No, this is too easy.
Oh yeah, there are questions. There are questions. I'm watching the queue joining up. So there's people on the chat raising a few questions, and can I ask you to jump to the mic? But we'll start off with Marie Jose. Go ahead.
I'm speaking as the co-chair of a group that we closed a few months ago, which was about network coding. And we did look into exactly what you're saying. Reed-Solomon, by the way, is not a really good solution for the type of long-term and very large data sets we're looking at. Also, Reed-Solomon requires to wait for the whole block to be delivered before you can actually start decoding, which means that there's an awful delay. Network Coding Research Group identified a number of solutions. The problem that we had is that a lot of these solutions were protected by IPR. And you need to take that into account, either IPR or licensing issues. I agree with you that the good one, which is in open source has been in open source forever, is Reed-Solomon. But I don't think Reed-Solomon is going to help you here. It's not good for long sequences. So while I completely agree with you that adding FEC could increase the reliability, and actually I would actually, as a professional in that field, I would actually say it's yes. But I think Reed-Solomon is I would say the lowest common denominator, and there's been, like you said, 30 years of research on things that are better. So I would like to know what other solutions have you looked that are not block codes. Block codes are extremely bad for the type of solutions that are looking for raw, because we need to have on-the-fly decoding, and there are on-the-fly decoding. If you look actually in the transport area, there's been a number of RFCs on related codes. Like I said, some of them are protected by IPR, some of them may be more open. I think there's probably some of this IPR that is now expired, but I am surprised that you call it tada, because it's not tada. It needs a very good evaluation of what is needed and what are the impairments of licensing and IPR.
Thank you very much. What I have done here, and my intention is that the block is the IP datagram. I've done what little I have done. By the way,
it's too long.
So it's potentially a very short thing they're applying it to. And I only stumbled on dealing with this problem 2 weeks ago. So my time and research on this is absolutely minimal. I've not done the proper research on the different facts which are available and which one may be best. I just grabbed something which was just easy for me to use this presentation. But the intention here is that because, as you point out, you need to do this on a datagram level, so you can do the encoding and decoding right at that packet.
Well,
you need to choose something which is good.
You should look at the
and we'll look, and we're looking elsewhere. We'll be, and I'll be love to talk with you and work with you and to be able to come with something which is appropriate to use that will work better. I only, like I said, just grab the first thing I could grab just to put it in and explain what could be done and what the approach would be. The next step is let's get real.
Agree. Anything that works with wireless and wireless type of error patterns is obviously helped by some form of error coding at the packet level, at the datagram level, or even lower. I'm not disagreeing with you here, but I will say that there are already RFCs in the transport area, and we've had a research group for I think close to 10 years. So I'm surprised. I was surprised that you did not mention that body of work. But it's fine. I will leave the floor to somebody else.
Thank you, Marie. Very valid point. And this goes back to my comment at the start of the session, is there's loads of IETF technologies out there. Perfectly valid for you to bring this, Bob. I'm going to give Pascal and Lou a chance to join the queue. But I think, yes, as you admit, you grabbed Reed-Solomon. It was an obvious, easy candidate for a short time. This is a classic example of let's understand what else is out there. But thank you. Pascal, go ahead.
So yeah, Bob, I have three reactions. First, that would be with the LP1 chair hat on. I really love the idea that you want to use Sheck to actually probably do the fragmentation and then add some more data, which would be the redundant data, basically, that the Sheck layer would use before, fully expanding the packet. I really love that idea. It's really a nice extension to Sheck. We are not chartered for that, but I hope that, I will push to get that chartered. I really love it. Now, I'm not making any assumption on whether that's Reed-Solomon or anything else, but just the fact that Sheck could be used, to actually do the work. Now, maybe there is a better solution, but I love this approach. Second is, I love also the fact that Marie-José came in and mentioned the work in transport, because at the last interim, we discussed that a lot of the things that we expect in the .NET architecture at the service layer are typically done usually in transport layers. And that's my point of view, not necessarily agreed with everybody, right? So my own chair at, my own hat on or whatever. But things like ordering is something that TCP typically does, and transport will do. Some transport will do, and reliability, FEC or ARQ or what, is also a transport, an end-to-end transport layer thing, which is exactly that. You're doing end-to-end reliability here. So this is typically a transport thing, and so yes, we probably need to have this discussion at some point of what of the .NET features of the service layer are really layer 3 versus whether effectively they are layer 4. And if we want to expand the work on them, should that work happen at transport or internet area? So that's the second reaction. And I had a third one, which is, yes, the .NET architecture includes effectively the sort of operation that you have, and Raw expects it. Not only adding FAQ, but also distributing the different objects that you generate over different paths. So they, even if there is like a solid block on the path of one of your 3 things, as long as 2 of them pass, then you make it through. And 2 to 3, just one number. It could be 5 to 7 or anything like that. But the idea of taking one big packet, could be 8K or whatever, fragmenting it in 2Ks because that's your .NET service guarantee, and getting 6 objects of 2Ks, and then sending that over a raw .NET. That's expected. That's really the sort of thing we want to do. And in particular in wireless, that's really the sort of thing I'd like to see happen.
Thanks, Pascal. Lou.
Super quick, just want to highlight that what Pascal just said. Network coding is called out in the .NET architecture as a possible solution to provide service protection. If you have a specific proposal, publish a draft, bring it to .NET. Thanks.
Just to Rick adding a chair comment, I don't believe, unless there was a compelling reason, that Raw would disagree with any network coding that was built for .NET, unless there was a compelling reason why it didn't work for wireless. We would just inherit that. So.
Absolutely, and if you needed some raw specific tailoring, this would be the place to discuss it.
Exactly. Go ahead, Adam.
Adam Whitaker.
The place, I'm sorry. We would just be the place asking .NET to work on it or something. That would be our role.
Absolutely, yeah.
Adam Whitaker. Another thing on this too, I agree with Marie completely on the transport stuff. And I was actually looking at Bob's stuff earlier, and the first thing I thought of was Norm. Yep. Norm is probably the right solution for this, and it's already been defined completely, but I was going to work with Bob on that anyway, off list.
Okay. So I'm going to add one last piece to this. With my chair hat on, thank you, Bob. This is a source of a valid discussion. Yes, there is lots of pre-existing work out there. It is relevant to us because it's a common problem in wireless is you get packet drop. Yes, it's relevant to .NET. Thank you for bringing it. I want to raise a follow-on question, which I thought you might have addressed, but you didn't, which is probably a subject to be chewed over by everyone in the room, which is we can build these reliable deterministic networks using a combination of .NET and Raw, where traffic flows have a certain scheduled bandwidth with latency and controlled packet size. And then if I run TCP over it, the sliding window is going to ignore everything and drop all the packets automatically. So I think there is an open question, and we may not be at the right point to start addressing this because .NET and Raw haven't really finished their work. What transport should be recommended to run over these systems from a general perspective, so you don't, unless you are an AV broadcast company where you have your own technology to run over it, that's fine, that's a solved problem. What if I'm kind of a small startup or a man on the street and I just want to do some REST-y kind of thing over a deterministic network for some reason? What protocol do I use for my transport? And that's an open question. To me it is. Someone got the answer, tell me.
And I've already had one pushback about you're busy reinventing TCP. Why are you doing that? But you just raised a point that maybe I do need to reinvent or at least educate TCP for this environment.
Yeah, that would be my question is, do we educate TCP to understand this? And is that then a .NET function? Or do we need a different transport? And from the experiences with things like SCTP, uptake with middle boxes, etc., is always an issue. I'm watching the clock. We have 1 minute for any other business. Thanks, Bob.
You're welcome. Thank you all.
Anyone else have? Carsten has jumped to the queue. Go ahead. Oh, sorry, Pascal's first. Go ahead, Pascal. Then jump in.
Yeah, I think our role here is not necessarily to educate TCP, but mostly to figure out the sort of things we would like to see happen. At least kind of all the services we could imagine that we would like the transport to be doing, and then pass the big packet to transport area and say, okay, what do you have for us? You know, so our role is not to decide it's TCP or not TCP. I mean, certainly I cannot do that, but at least I can, you know, knowing the performance of my network, you can say, hey, I would really love a transport which can do this, and this. That's how.
Thanks, Pascal. Carsten, go ahead.
Yeah, just a quick comment. I think we have to be careful that in making the network more reliable, we don't start applying the transport service model to the network. There is still an end-to-end argument here, and a lot of people seem to think that we can change IP so every datagram that is ever sent actually arrives, and that's not going to happen. So let's not try to change the IP service model. And given that IP runs on a concatenated network, we will always have the situation that various parts of the network have different cost structure in actually achieving that reliability. And that really has a lot of implications for the service model. So I think we need to have a service model discussion.
Yeah, I think this is a huge topic and is interesting. I'm not proposing we do it in Raw. I'm not even proposing we do it in this area. But yeah, I think it's one of those cool things the IETF was born to do and to look at and argue about. Go ahead, Adam. We're running out of time.
Yeah, very quick. Agreed with everything that Carsten just said, and also skips TP is another great thing that should be utilized here.
Okay, I'm going to close the meeting. Thank you very much, everybody, for attending in person or remotely. Hopefully we'll see more of you in person in London, because it's always nice to see people face to face. But stay safe, and we'll see some of you at the interims. Communicate on the mailing list. Please state your support for Ldx if you have support for Ldx. It's important to get that work moving. Otherwise, thank you very much. Enjoy the rest of your day.
And thank you very much to all of the people who have been helping with the minutes. They're superlative.
I never know how to close a meeting. There's no end button. I hang up and it ends.
I think so. I think when the last person leaves, it ends.
Yeah, you can leave. So that's a signal that the meeting is no longer running.
And it will time out at some point after the hour. I think it's maybe 10 minutes, 5 or 10 minutes.
I've left, Eve. As soon as you leave, I think something triggered the guts of it.
Okay, I'm going to leave. Bye-bye. Thank you, everyone.
Thanks, Eve.